All right, hello everyone. Mrs. Pesic here. We are going over some homework problems from section 1.6. This is problem number 44, and this is live. I'm live with block 4. Block 4, you want to give a shout out? All right. Okay. So in this problem, you had to enter data, and you did that. And then it looks to me like it clearly is in two different pieces. Would you agree with that? All right, so we got one piece that's kind of curving up into the right and one piece that's kind of sloping downwards. So they're giving you a mathematical model. Did you enter this mathematical model?
Yeah.
Yes? I'm only seeing one piece of this model. You got two pieces? That's what you have?
I didn't do a list. I have that one. Yeah, I did on the ground.
Oh. Okay, so when you go menu, analyze plot function, is that what you did? Do they allow you to set it up where you can put your own descriptions in? Like, can you make a piecewise function?
Yeah.
You did that. But what happened to the other piece? You just didn't put anything in because they didn't give you anything.
So what I did was I went here.
Yeah.
Plot function.
Yeah. All right.
Like that.
So-
I did, little button right here.
Perfect.
Right? And I did
Oh,
that.
you know what? Let's do 2 to the left of that. That's the one I want. Nope. Yep. There. That one. Let's do that instead, and let's make up something. All right. Let's do the negative 1.97x plus 2.63. But I mean, for me, it looks like maybe up to 6. Like, can we say? Can you just do a tab? There we go. And let's do 0 is less than x, and x is less than 6. All right, you're all doing this with Mark?
Is this supposed to be on graphs or just?
Yeah, I can find a graph.
I want to be able to see it over the data, right? So if you do it on a graphs page, we can't see the data, can we?
So,
No. So let's try it like this, and then we're going to do the other. You're entering the other function, correct?
yeah.
And that other function, 0.505x squared minus 1.47x plus 6.3, and let's do a little tab over there, and let's make that from, that looks like maybe it starts at like 6, yeah, let's say 6 to 13 or something. 6 is less than x, and x is less than 13.
We do add an x and spreadsheet. Are you doing that or x and y?
Right now, we're just trying to see how close a fit the model that they gave us is if we choose our own x's. And I don't know whether the authors on purpose wanted to leave that out or not.
How do you get to this part? Lost. Like, I don't understand where this is.
What happened? Oh. Okay, pause. This is a great teachable moment. Hold on. Just say escape, escape. 2 times. That's it. Stop right there. Here's what I noticed, and we'll get back to your question, Mallory. You had a question in just a second. Hang on. But what I noticed is I was thinking, oh, this is the first part, and let's make it 0 to 6. But what I'm noticing is this one negative 1.97. This one, right? So I think, Mark, that I want you to switch these two, put the 0 to 6 here, put the 6 to 12 here. And it's okay that one's on the top, one's on the bottom.
I want to get rid of this one that I plotted before.
Yeah, just, yeah, right.
That was not so. Mark, how do you know that?
So the function remove this.
So we got rid of that. Now you're gonna go back.
Thanks, so.
Okay. All right. Is it working? Anyone have it spinning around? Remove. No, yeah. Don't. Well, you don't have to remove that one. We're just editing that one, right?
Yeah, just click on it.
Yeah, so click on, just double click on that so we can edit it maybe.
Oh, there we go.
There we go. And switch that to 6 to 12 in the top, and then 0 to 6 for the bottom one. All right, how's that looking?
Should be,
I would not get worried about that. That looks like a pretty good model now, doesn't it? Everybody agree? I mean, I think it's kind of nice that the authors didn't put it in for us, so we could kind of investigate and see how far each piece should be, right? So I like that piece. We did that. What is the domain for each part of the piecewise function? I think we just decided that. The domain for this first piece is 6 to 12. The domain for the second piece would be like 0 to 6. Everybody agree? All right, and then it says find f of 11 and f of 5 and f of 11 and interpret your results. Here's what I want you to do, Mark. Can you do control dot? First of all, pause for a second. Notice that on Mark's, this has F2. Maybe yours is F1. Maybe yours is F6. I have no idea where you're at, but Mark's is F2. Can you do control dot, add a page? And you are going to a calculator page. And I just wanted to do F2. Now, you guys might be doing F1 or F6, whatever you're on, but Mark had F2, left parentheses, 5, right parentheses, enter. So it should be 11.575. And then can you do F2 of 11 also? All right. I mean, you could plug in 5 into the individual functions now that we know which the domain is for which. Does that make sense? Yes? All right. And then interpret your results in the context of the problem. Well, F5 would be month 5, correct? So what is that, May?
Yeah.
So in May, the revenue is 11.5 $1,000, right? And F11 would be what, November?
Yeah.
Yeah. All right, and that's the revenue in November. Questions on this?
I did the domain for that.
How did we figure out to switch those domains?
I just figure out what the domain was. Doesn't say in the top.
Correct. Mark, can you do control left click so we can go back one page? There we go. So what we tried initially, I said, oh, it looks like these dots here are one function, and these dots here must be the other function. And I just assumed, wrongly, that the first equation they gave us matched up with the left set of dots, right?
Yeah.
And that the second set of dots matched up with the second equation. But once what Mark graphed originally, though, for this line right here was over here. Show up on my board, yeah. And then this one, we saw a little curve like this. I was like, oh, that's not right. That's the line, but we want it over here. So I had add 0 to 6 for this, but instead we wanted it 6 to 12.
Okay.
And then we had this little piece of this quadratic function, but we didn't want it from 6 and beyond. We wanted it from 0 to 6. So then we switched it around, and you see the results that we got. It looks much better.
Okay.
All right, questions on this one? Nice problem. I like this. And did I assign number 47?
Yeah, can you do that?
Yeah, no one asked about that one. All right, let's talk about number 47. All right, for 47, this one we're going to do together. This is section 1.647. It says during a 9-hour snowstorm, it snows at a rate of 1 inch per hour for the first 2 hours, at a rate of 2 inches per hour for the next 6 hours, and at a rate of 0.5 inches per hour for the final hour. Write and graph a piecewise defined function that gives the depth of the snow during the snowstorm, how many inches of snow accumulated from the storm. So in this case, the first thing I want you to do is make a table. I want you to make a table first. All right, and I want your table to be hours and total snow accumulation. All right. It says during a 9-hour snowstorm, it snows at a rate of 1 inch per hour for the first 2 hours. So I'm assuming that initially, at time 0, there's no snow on the ground. Would you agree with that statement? So we got 0, 0. What about 1 hour later? How much snow is there? 2, it's been snowing for 2 hours, correct? And how about 2 hours later, how much snow is on the ground?
2.
Still 2? It didn't snow at all between 1 hour and 2 hours? Ally Beth? 4, right? It's snowing 2 inches per hour. So after 2 hours, we had 4 inches on the ground, correct? We're talking about total snow accumulation. Then it says, at a rate of, it snows at a rate of 2 inches per hour.
Yeah.
Wait, did I mess this up?
Yeah.
Okay, I didn't read it carefully enough, my bad. So what should it be? Now, don't worry, because you're all looking at it.
It should be 1 and then
1 inch
2.
per hour.
Thank you. 1, so there's only 1 inch on the ground after the first hour,
Next one's 2.
2 inches on the ground after the second hour. Now are we all feeling better?
Yeah.
Okay, I'm feeling better because I was thinking, oh my gosh, these guys are not getting it. No, okay, so, all right, so what about now the next, how many hours? 6 hours?
Next, yeah.
So I'm gonna put 3, 4, 5, 6, 7, 8. That would be my next 6 hours. Agreed? All right, and now it's snowing at a rate of, now it's 2 inches per hour, correct? So how many inches on the ground after hour 3? 4. 4. How about after 4? 6. After 5? 8 after 6? 10 after 7? And after 8? 14. Let's keep this going here because this snowstorm is not over yet, is it?
No.
And at the rate of 0.5 inch per hour for the final hour. So there's 1 more hour of the snowstorm. So I got to get to hour 9, and then how much snow is on the ground at that point? 14.5. All right. So here's what I want you to do. Now that we have our table, you certainly could plot these points on a graph. All right. Pulling up our graph.
Crazy,
Searching, pictures. Not the best, but we'll take it. So for this, I don't like it already, but humor me on this, and let's make this our y-axis, and we're going to make this our x-axis. All right? You should all do this on graph paper, right? I'm assuming if it doesn't say use a graphing utility, that you're using graph paper for this, correct? All right, so if I'm plotting this, here's 0. Let's see. Yeah, I'm gonna make this 1, 2, 3. These are my hours here. All right, and then over here is total snow. So my graph should look like this: 0, 0, 1, 1, 2, 2. That look right? And then 3 goes to 4. Uh-oh. Yeah, I got enough room. I don't need that many hours.
Yeah, you need 9 hours.
9 hours.
Thank you, Mark.
And then,
No.
yeah, thank you. And then total snow, I need to get up to 15. So this is 1 inch, 2 inches in inches. All right, so this is 5 inches and so on. So how am I doing so far? Okay, and I gotta get all the way up to 814, which I think is right here. So far, I'm connecting, I got this piece here connected to this piece here. Would you agree with that? Yes? And then I got one last piece that is going from 8 to 9, and it goes from 14 to 14.5, like this. Are we okay with this? So your task now, table came first, graph came second, at least that's how I'm recommending that you do this. And now we need to write our piecewise function to fit this data and this graph. So I think our piecewise function is going to be how many pieces? 3 pieces. And so for my first piece, I think maybe we'll just do the first one, second one, something like that. So if we just do the first one, I just need the equation. You can look at the graph if you want to figure it out. I would probably just pick any 2 of these ordered pairs between 0 and 2. Like I can pick these 2, or I can pick these 2, and what am I going to do with them? I'm going to do find the slope find the y-intercept, right, and write my equation of my line. What's my slope for this? Gotta be 1, right? I'm doing a difference in my y, so 2 minus 1 over difference in my x's. I'm getting 1 over 1, which is 1. My slope is 1. What's my y-intercept? And this one, we can figure out the y-intercept pretty easily. It's going right through 0. So my first equation is 1x plus 0. Now, you don't have to write 1x plus 0. You can just write x. Would you agree with that? And we only want this graph between x being between what and what?
0.
Between 0 and 2. All right? Now, by the way, I put less than or equal to. It's okay to put less than or equal to here or strictly less than. It's just here when I'm going to do my next part, it's going to be between 2 and, what was my next one? Between 2 and what? 8. I cannot put, less than or equal to in both places. That would be a no-no, right? You got to choose where you're going to, pick one of them. They're connected, so it really doesn't matter where you put that equal to. Does that make sense? All right, so for this one, I'm trying to color code this. So for this one, this is 2 is strictly less than x, and x I'll say less than or equal to 8. And now I would pick any 2 ordered pairs. They don't even have to be next to each other though, so I don't have to use my little box. I'm going to pick any 2 ordered pairs between 2, 2 and 8, 14. Like I could pick 6, 10 and 3, 4, and I want to find the slope. So that'd be 10 minus 4 over 6 minus 3 with me. And I'm getting what? 6 over 3 is 2. Is that a surprise that the slope is 2?
No.
Connor, why is that not a surprise?
So 2 inches per hour.
It's snowing at 2 inches per hour. That's your rate of change. That's going to be the slope that we find. And we do need to find the y-intercept though, so we do need to do y equals mx plus b. I would just pick one of these ordered pairs, like the 6, 10, and I get 10 equals 2 times 6 plus b. Does that make sense? And I am getting 10 equals 12 plus b. Subtract 12 from both sides. I'm getting what? -2. So b is equal to -2. So what's our next equation going to be? I'm sliding this over a little bit to make room, and sliding this guy over, this guy over. And what is this next equation?
2x minus 2.
2x minus 2 for x between 2 and 8. Does that make sense? All right, I'm putting a big dot, dot, dot on this problem. That means I want you to finish it up. I just left you with the last piece, and that's probably when you're going to just find the slope and write the equation of the line that goes between 8 to 14 and 9, 14.5. Does that make sense? So you finish that one up. Is there anything else from 1-6 that we should talk about? Okay. All right. So at this point, I am going to stop this video. Thanks for watching. Okay.